Hi guys! Alright, so we're going to do a review for Chapter 7. Welcome to Logland. Yay! Alright, so like we talked about in class, we know that log base b of x equals y and b to the y equals x. So this is log form and this is exponential form. So we're going to start with taking a logarithm and rewriting it in exponential form. So my base is 5. I raise it to my answer, which is 3, and it's equal to 125. And if you check that in your calculator, it's correct because 5 to the third power is 125. All right, so next I have an exponential equation, and I want to write it in logarithmic form. So I have my base, which is 3, so I write log base 3 of 243 equals my exponent. So the next thing that we're going to do is we're going to expand a logarithm. So I know that because of these three properties here, I can take this logarithm and expand it. I can stretch it out. So I'm going to break it apart first by undoing this multiplication here. So I rewrite it as log base 4 of x squared plus log base 4 of y cubed. The next step I'm going to do is I'm going to take these exponents and put them in front of the logs. And we are allowed to do this because of the power property. So I'm going to have 2 log base 4 of x plus 3 log base 4 of y. And that is my logarithm expanded. So next I'm going to write the expression as a single logarithm. So I'm going to do the opposite of what I did before. So first thing that I need to do is I need to check to see if I need to raise any logs to the power. I'm looking at this one right here. I have this 4 in front. So I'm going to rewrite this and raise x to the power of 4. This way, I don't have anything in front of my logs. Next, I know that if I am adding, that means I'm going to be multiplying. So I'm going to combine x to the 4th and 7. So I rewrite it as log base 3, 7x to the 4th. I write the 7 in front of the 4 because it is the coefficient of the variable. And that's it. Next, we're going to be using the change of base formula. So if we have log base a of b, we know we can figure out what this is if we take log b and divide it by log a. And you're going to want to use your calculator for this one. So to use the change of base formula for log base 3 of 16, I'm going to rewrite it as log 16 divided by log 3. You really want to make sure that you use parentheses when you're adding this into your calculator, especially if you have something in front of the log. So when you enter this into your calculator, you should get about 2.5237. And that is your answer. So now we're going to get into solving. So here we have an exponential equation. We have 25 to the 2x equals 125. And so on this one, I'm telling you, solve by using the same base. So that means that I can have the same base on both sides. So I'm going to use a base of 5 because I know 5 raised to the 2nd power is 25. Don't forget to put the 2x there. And I know that 5 raised to the 3rd power is 125. So now I can solve because I have the same base. So since I have the same base, that means I can just cancel these out, and I set the exponents equal to each other. So I have 2 times 2x equals 3. I multiply and I get 4x equals 3. And then I solve for x by dividing 4 on both sides. So then I'm going to get x equals 3/4. So for this next equation, I have an exponential equation. And before I do anything, I want to make sure that my exponent and my base are isolated. So I'm going to move 3 to the other side. So I subtract 3 from both sides. And I'm going to get 5 to the x equals 9. Now I can't write a base that is the same with 5 and 9. So this is where logs come in. So I'm going to rewrite this equation as log 5 to the x equals log 9. And then in order to isolate x, I'm going to move this x to the other side by that power property. So I'm going to have x log 5 equals log 9. And then the next step is I'm going to isolate x by dividing both sides by log of 5. So I'm going to write it up here. So I'm going to have x equals log 9 divided by log 5. So this is something that you're going to need to do on your calculator. And when you do that, you should get the answer of x equals 1.3652. For our next equation, we're going to be solving this logarithmic equation. And what we want to do is kind of just like before, we want to isolate x. So in this case, we don't have a base for log. So when we don't have a base for log, we know that it is base 10. And so since I have an equation, I know what my base is, I can rewrite this logarithm as an exponential equation and therefore solve it. So I'm going to start by bringing this 2 up in front of this x plus 1, essentially rewriting this power. Now, if you remember, with our exponential equations, our base to the y equaled our x, right? So our base here for log, if we don't have one, we know it's 10. So we're going to have 10 to the 5th power equals x plus 1 squared. So now that we have this, we know that 10 to the 5th power is going to be, I believe it's 100,000, and that's going to be equal to x plus 1 squared. We want to undo this square by taking the square root of both sides. The x plus 1 squared just becomes x plus 1. And then the square root of 100,000 is about 316. Now, since I'm taking the square root, that means it's plus or minus. So I'm going to rewrite this over here. And I'm going to say x plus 1 equals plus or minus 316. So that means that x plus 1 equals positive 316 and x plus 1 equals negative 316. So off the bat, oh, actually, hold on. So let's solve for x. So I subtract 1, and I get x equals 315. Subtract 1, x equals negative 317. So I cannot have a negative log. And then our answer will be 315.